Okay, welcome class, my Math 150 class. Today we're going to start off this semester by talking about section 1.1, which is functions by formulas. So to start this off, I need to go over and clarify what exponents and what they really mean. So I'm going to demonstrate this by several examples. One is 3 squared. Now 3 squared, the common mistake is 3 times 2 is 6. That's not what this means. What 3 squared means, that square means you have 2 3's that you're multiplying by. And in this case, 3 times 3 is 9. Now, let's take a look at three to the fourth. This is saying 3 times 3 times 3 times 3. Okay, now notice, how many 3's do I have? I have 4. That's what this exponent right here tells me. So now what I'm going to do is I'm going to say, okay, and if you don't have a calculator, just do this. What's 3 times 3? It's 9. 3 times 3 is 9, and we're multiplying, so 9 times 9 is 81. Now, what about 3 to the 4.2? What does that mean? Well, first of all, if you look at this by writing it down, that's like saying, okay, I got 1 3, 2 3, 3 3, 4 3, but now, is that 0.2 right here? That doesn't make any sense. So if you look on your calculator, and most of us that have the TI-83 or TI-84 Plus, if you look on the right side of your calculator, you will see a little arrow that looks upside down. This is called the caret button. So all you'd have to do is you'd have to put in 3 raised, or that little caret symbol. It's on the right. It's right under clear on your calculator, to the 4.2, and you will should get 100.9. And you could go back up to your other ones as well and do the same thing, like 3 squared, 3 to the fourth, and it gives you the 9 and the 81 respectively. Okay? Now, functions are concerned. Okay? Now, function, what I'm going to do is you're going to see this through the semester. We're going to just use a letter. I'm going to use F for function for this case. And if you look right here, I've got this circled X. What this means is that's the variable. That means in our equation over here, that X to the third, this X is the variable that's in the parentheses. Okay? So now what we need to do is we need to go through and to substitute these in. So what I want to do, just to save a little time, is I'm going to just go ahead and put 4, 5, and negative 6 to the third powers. Okay, now we can go ahead and put these in our calculator, which is perfectly fine, but I'm going to do this by hand. So what does that 4 to the third mean? Well, that means that's saying 4 times 4 times 4. Is 64, or you could do 4 to the third power. Okay, now let's do 5 to the third. That means you got 3 5s you're multiplying. 5 times 5 times 5. There are my 3 5s. If you do this, it's also 125. Okay, now I'm going to show you a little thing that I like to do when you have negatives. Now, if you have a negative, that's like saying negative 6 times negative 6 times negative 6. Now, the 3 is an odd power. So that means you're going to have an odd number of exponents, or I'm sorry, of negative signs. So since you're having an odd number, that means the answer is going to be negative. So you'd say 6 times 6 times 6. Okay? So this should come out to be negative 216. Now, for calculator's purposes, what I would advise everybody to do is, especially when you have the negative exponents, or the negative with the exponent, is put in negative 6 like this raised to the third power. Whether this 3 is odd or even, you need to always, whatever that exponent is, always, if you're dealing with negative numbers, put it in parentheses. Okay? Let's work on these. Now, what I advise us to do at this point is maybe pause. At any point, you can pause this video, take your time, and then come back when you're finished and see if you've done this correctly. Okay, so the first problem is negative 2 to the fourth power. Now, I'm going to do this by hand. You can do this by calculator, but I'm going to do this by hand. Negative 2, so it means I've got 4 of those. Now, notice something. Since 4 is an even power, watch this. The negative and negative makes a positive. The negative 2 and the negative 2 right here makes a positive. So that means, what's negative 2 times negative 2? It's positive 4. What's negative 2 times negative 2? Positive 4. And then 4 times 4 is 16. So notice my rule. If that's negative, the number's negative. On an even exponent, your answer is positive. Okay? Now, let's look at the 3. You got 4 3s. And since there's no negatives, it's going to be positive. So 3 to the fourth, we've already seen this. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay? Now, one of the big mistakes are my last 2 examples. Okay? Now, what I mean by that is, it's easy for me to say 1 to the fourth power is 4 because we're thinking 1 times 4 is 4. But that's not the case. What you want to do is you've got, look at this. You've got 4 1s. Now think about your 0. Same concept. That means you've got 4 zeros. So 0 times anything is 0. Doesn't matter how many zeros you have. And in part C with the 1, it doesn't matter how many 1s you have because the answer is going to be 1. Okay? Now let's take a look at this next one. Okay? It is, and that should be a negative m. Okay? So notice in my parentheses, I've got an m and I've got a negative m to the third power. So here's what I would do always, is I like using parentheses. So what I'm going to do is I'm going to start off with negative. My negative 2 I'm substituting for m, so I'm going to have a negative 2 to the third power. Okay? Now, this is like saying negative times negative 2 times negative 2 times negative 2. So you've got how many negatives? 1, 2, 3, 4. They all cancel each other out because it's even number. So you'd say, what's 2 times 2 times 2? It gives you a positive 8. Now, as far as your calculator is concerned, you put this in your calculator, I would write it just like this. Negative, and then in parentheses, negative 2, like this, raised to the third power, just like this. Okay, my next example. Now, you're going to be dealing with two terms we're gonna use throughout the semester is functional notation and to evaluate. Well, functional notation means what are your values. So what you want to do is you want to look at this f m comma n. So I want to say, okay, this is what I'm looking for. That's my functional notation. I do have values that are assigned. So in this case, this would be f, m is 8, n is 25. Now to evaluate it, that's when you would substitute those values in to get an answer. So if you evaluate this, you would get m, so 8 to the third over 25 to the third. Okay. Now, I know this is going to be kind of a big number, so you want to put this in 8 to the third power. That's like saying 8 times 8 times 8, which gives you a grand total of, let me put it right here, 512 over, and then you want to do 25 to the third power. It's going to be a bigger number. It's going to be 15,625. Now I cannot reduce this anymore because your 8 and your 25 does not reduce. Okay. Now what about I have this f of m comma n. Now I've got the square root of m plus 1 over n to the third minus 2. Well, in this case, what I want you to do is, okay, we're going to substitute this in. So I'm going to take square root of 6 plus 1 over n squared, so that is 7 to the third power minus 2. Now the square root stays on the top. It does not go to the bottom. 6 plus 1 is 7. And then you would say, okay, what is 7 to the third power? 7 to the third power is 343. Subtract 2, and you get 341. Now this is, if I don't ask you to put it in like decimal form, you can leave it at this. But if you want to evaluate it, what I would do is I always like putting in the denominators parentheses. So you would say square root of 7, hit enter, divided by 341, and you should come up with a small number, 0.00775. So it just depends on what they want you to do. If they say, okay, round it to the nearest, say, thousandth, then that could be 0.008. So they would specifically tell you what to do. And I know I kind of jumped the gun a little bit because I wanted to explain this evaluate. So I did part B first, just because that square root usually throws people kind of in a loop. So I wanted to get that out of the way first. Now the functional notation itself, all I'm looking for, okay, is this part right here for functional notation. It's f, okay, what is m? Because m is first right here. M is 6 and n is 7. That's all I'm looking for functional notation. Okay, I've got a few more examples and I'm finished with the first lesson. Okay, let's see. Okay, what about if I have 7a plus 5b over 3c? And I'm just going to, in this case, what I want you to get used to is functional notation is just f, and then your A is 7, B is 9, C is 11. And then when you evaluate it, all you're doing is you're saying, okay, I've got 7, what goes in parentheses, plus 5, what goes in parentheses, over 3 times what goes in parentheses. Well, my A value is 7. My B value is 9. And my C value is 11. Now, how I would continue to go about this would be, is, okay, what is 7 times 7? It's 49. What is 5 times 9? It's 45. And what is 3 times 11? It's 33. Now, the top, you could say, okay, what is that? That's going to be 94 over 33. And you could leave it just like this, or if I tell you specifically, you can put it in a decimal form. Now, one cool thing you can do is, since this is 94 divided by 33, if you look on your calculator on your left side below alpha, so you've got your second button, which is a colored button, then you got another colored button, alpha, and then math. If you go to math and hit fraction and type in, once you type in your fraction, hit enter, and then you can put in your fraction, decimal, it will bring it back to a fraction. This can also use, you can also use this to reduce fractions. So I'm going to kind of put this to the side right here. So if you go to your math, like I said, on your right side, and you hit enter, and then it'll come with fraction. This right here will put your decimals back into fraction form in the lowest terms. The next, I've got this 10, number 10. It's 4 plus e to the fifth. Now, E is one of these special, you can say symbols. It's almost like the pi symbol. E is technically a value. E is technically 2.71828 and some numbers behind it. A lot of times you'll see people use, which I've seen before, 2.72. They just round that 1 to a 2. Now, so E has a value, but if I give you a problem like this, what you want to do is you want to put this in your calculator as 4 plus, and then E raised to the 5th power. And once you do this, you should get, once you say 4 plus, now your E button, if you go on that left column of your calculator to the LN, you'll see it towards the bottom. If you hit your second button and LN, that gives you your E raised, and you just put in your power. So you want to get this E, you want to say second, and then your LN button. And what that will do is that it will give you E raised to, and then you would put in this case, the 5. Okay, so once you do 4 plus E raised to the 5th, you should get something like 152, 0.41, and so forth. Okay, my final piece of this puzzle is, let's just say Mary makes $40 an hour. Well, who wouldn't like to make $40 an hour? That's a pretty good rate. So usually $40 an hour, you may think of like maybe nursing or something like that, but $40 an hour. Okay, so to put it in functional notation, okay, so I'm going to say, okay, we all like money, so I'm going to say functional notation would be M, and how much money does you make depends on what? It means how much time you work. So you can use M of T if you want to. I'm going to use H because usually we use T or X and Y. I'm going to just use H for the the hours. So M of H equals, what would be a good formula for this? Well, M of H equals, think about this for a second. Think about a typical work week. We think of 40 hours. So I'm going to just do 40H. Okay. How much does she make in part B? How much does she make in 40 hours? Well, what I'm going to put is I'm going to say M of 40, because now that 40 means hours. That means, so I'm going to put that new 40. I'm going to keep this formula green on this case, that 40, because that's a constant. That means that's going to always stay the same. And then what I'm going to do is in parentheses, I'm going to put the 40. So $1,600. And finally, how much would she make, or how many hours will it take her to make $1,200? Well, in this case, we're going to do reverse. The make, we already know. The money, we already know. So what I'm going to do, this is starting to understand formulas. So you got 1,200 equals 40H. So that means how many hours will it take us if we make $40 an hour to get 1,200? Well, in this case, 40H. How do you get rid of the 40? Well, this is 40 times H. So what I like to do is, since it's time, you always do opposite. So I'm going to divide, because what do the 40s do? They cancel each other out. But if you do one side, you have to do the other. So how many times is 40 going to 1,200? So that means H means she's going to work a total of 30 hours. Now, I know some of us may be just watching this and maybe not in this class, but if you're in my Math 150 class, go to your WebAssign homework number 1 and be looking for some announcements. Thank you very much for listening, and our next video will be section 1.2, doing functions and formulas from tables and charts. Thank you for listening.